right now, but go or onto the this cursor here. But if you go on to Bitbucket, and this isn't the one we're looking for, it's one of Mohammed's. But if you go to your own repo, there'll be a sync over here. Make sure you sync, and then after you sync, then you can go back to git bash or terminal and do a git pull, and then clustering, I believe, is the one that should be in there. So what was the last one? Clustering script updated. So yeah, so there's some commits in there that Mohammed put in there of the clustering script in there. I also put up class 2 and class 3 on the drive if you're really having trouble with using Bitbucket. So if worst case and you want to look at those, they're on the drive, but it would be great to learn how to do git bash or Bitbucket or repository stuff, because it really does change the way that you interact with coding. Now Mohammed's going to do clustering today, and then tomorrow we'll do R packages and maybe some hyperspec. Good.
A little introduction to hyperspec. A few minutes.
Yeah, probably like 10 to 15 minutes. Hyperspec.
So today we will get some basic introduction into clustering. So what does clustering do? It takes a set of data and like clusters or like divide this data into some of the subsets based on some of the property of the data sets. So today we will do some clustering with Iris dataset. So let's look into what Iris dataset looks like. So Iris dataset is already in there, so just I load the package into and save the Iris data into data frame. So you can So here we have what Iris dataset looks like. So it has like 5 columns. The first column looks the sepal length. It's like a three flower types data. So first one is like flower sepal length, then flower sepal width, petal length, and petal width. And the last column is the species. So that's where we define like what is the flower actually looks like. So here we will try to like classify the flowers based on the sepal length, sepal width, petal length, and the petal width into 3 classes of things. So to make this thing interesting, so first we remove the species column from the data frame. So now if we look into the data frame, so there is no species column. So we save the species column into the variable called species and just remove the data. So now we can look into what the species looks like. So it shows like in the summary, you can see there is like 3 types of species and everyone is like 50. So there are many types of clustering in the statistics. Like one of them is like k-means clustering. It's a very basic clustering but very useful one. People say like it's an unsupervised clustering. So if you don't know anything about the data or anything, like you can try this one. Like it can show like how many clusters in there, what should be the optimum number of clusters, and like this. So for k-means clustering, to run the k-means clustering, first I want to define a function that calculates like how many clusters should be there in the data. So this function called WSS plot, it actually calculates the like sum of squares inside the data. So just I source the data function. So the function is over here, and from the function you just run the cluster. It shows you the plot. So this is a like a basic plot where you can determine like how many clusters do you need. So you can make one cluster of the data, two cluster of the data, 3, 4, 5, 6. And for each cluster, how many within sum of squares within the clustering group is decreasing. So this is what we call like elbow point. So in the clustering, we try to find the elbow points. So here you can see like after 3 within sum of squares, like is pretty flat. So here we can say like optimal number of clusters is 3, or you can call it like 4. It's your choice. Since we know there are like 3 type of species over there, we can say like okay, 3 is the cluster. But if we don't know like how many clusters within the data distribution, we always use like this type of elbow graph to find out the optimal number of clusters. So now we know we have like 3 clusters in there. Now we try to run the clustering. So before running any clustering or any machine learning technique or anything else, there is an important thing to set a seed. So here I am trying to set a seed like 1, 2, 3, 4. You can choose a seed like anything. So why do you want to set a seed or seed number? It's very important to set a seed because if you want to do a reproducible result, setting seed is important. If you don't set seed, it will show different result for different times. So like if I set seed here 1, 2, 3, 4, let's run k-means clustering. So for k-means clustering, the basic command is k-means. Then you give the data frame. Then you say like I want number of clusters like three clusters, and what is the iteration number, like how many times it will run the clusters. So for our case, like we give the data frame TF, and we say okay, we want number of cluster 3 and maybe maximum iteration 1000. Since the data set is very small, 1000 iteration doesn't take that much time. So, and we save the clustering values in the k-means.fit. So let's see what's inside in the k-means.fit. So if we check the attributes of the k-means.fit, it has like okay, clusters, cluster center. This is total sum of squares, and this is within sum of squares. So these are the values that defines the like how many clusters we need. Like here we can say like this graph also sum of squares. This sum of squares comes from like these values. And then like we total within sum of squares, what is the size of the clusters, how many iteration is there, and if there is no. Okay, so let's see like how many clusters in there and what type of cluster is there. So we define like 3 type of cluster. So they define it as 1, 2, 3, and it's distributed like this. You can see the clustering size. It says like the type 1 cluster is like 50, type 2 is 62, type 3 is 68. But if you can remember what we see as summary of the species, there is like each type of cluster is like 50. So this k-means clustering, it defines one cluster perfectly. There is some error in other 2 clusters. So this is just a start. We didn't tune anything. It's just like a basic plot. It defines the cluster in 3 ways, but there is some error also in there. So you can plot this cluster, and let's take a look. So this is the distribution of the cluster, 3 clusters. So it defines this cluster like very well. There is some anomalies here, like some of them are red. It defined as like a green, and green as a red. So the problem is here, but it can define this cluster very well. You can also give the So it defines the number one Sethusa cluster is perfectly number two cluster. It defines or distance value, define the methods. So the main thing of the clustering of this supervised clustering is the distance method. So how can you measure the distance between 2 points? There have been many methods for this thing. So one of them is Euclidean method. For Euclidean method, it defines the distance between 2 points as a Euclidean way. So between A to C, it will be A square plus B square. So if you can just Google it. This is the Euclidean distance. So if you go to position 1 to 2, it takes position 1 to 2 and how do you go there? And it takes all the square value and take the square root of it. There is another one called Manhattan distance. So this is it sums up how many blocks you travel. It doesn't connect A to B. So if you go this YOLO way, it will sum up all these YOLO values. So there is other different types of distance values. So first one we try with Euclidean. So first try to measure the distance matrix. So for distance matrix we use the function called DIST or distance. So just calculate the distance matrix. So you can see a distance matrix here of class distance, and it calculates all the variables between. So we can see the numbers here. And so now we try to fit a hierarchical clustering, and we choose a method word. There's so many methods here you can choose from. So word is the first method, then there is single, complete, average. We can choose any of them. So if you can choose word, we can see it has been done, and we can plot the cluster. And clustering looks like here. So this is the hierarchical clustering using word method, and from this thing, it's pretty tough to define which one belongs to which cluster. So we know we're looking for 3 clusters. We can define okay, so from this one try to find those 3 clusters we're looking for. So we can do that. So we can do that with a function called cut tree. So let's look into cut tree function. So cut tree is so this is a tree-like structure. So cut tree divides a tree into group of data. So the uses of cut tree give the tree functions and how many groups you want to divide. So we just divide it in 3 and put that here, and you can see it separates the cluster into 3. Mm-hmm. But still, the graph is not pretty. You cannot see all these values, and you cannot define okay, which are right or which are wrong, because we know the exact value. So to make it more prettier or more useful, we use ggplot and color space and 10 extent. let's try to measure the distance matrix again. So this time we will use, previously we used Euclidean, this time we'll just try Manhattan. We use a different hierarchical clustering method here, like maybe complete or average. Now here. So now the clustering looks a little bit different. Now you can see like the sub-tree section, like where each one is split. So you can again do a cut tree here. You can define like where each of the thing.
That looks like your old one.
That looks like my whole one. Yeah. So let's make this one more beautiful. So if you look into the final T-plot clustering, it looks like this. So this is like much more robust graph, and you can see like where each of the cluster looks like. And you can find the error from easily. So it defines three clusters as three colors. So these three colors, pink, green, and blue. You can see the pink are here, green are here, and the top of blue. So you can see like this is a blue cluster, and here you can see this is a pink. So that's the error one. And you can see some of the error here, like blue, here the green is mixed. And you can see the green is like pretty much here because the green, they define the green very correctly. So this way it gives you like a more robust way to define the clustering. You can see where each one is located, and you can find out like, okay, what are the errors and everything. So this one we did with ggplot with color space. So for this one we first defined the color branches. So like we want to do a color branch, like each branch will have a different color. Then I manually do a coloring like red, green, and blue with this function and give a label. And finally I did something like with the labeling, like making the label small. If I do with like label 1 here, so it's like too big. It overlap with one another, so we cannot see anything. So I just redo the label here with 0.5 or 0.6, and I redo the margin. And now let's see. So this is like hierarchical clustering with the method word, and you can try other cluster and you can like link them between them and see like if there is a difference between them, what are the difference, and we can move from there also. We can also include heat map in clustering.
And so the metric you'd want would be to get your misclassification error rate.
Yeah.
You could try lots of different distance metrics and evaluate your error rate since you already knew the right answer.
Right, yeah. So yeah, if we know the right answer, then we think we can do that. Yeah. And so another one, we look into heat map clustering. So it's like more advanced clustering. So now like you can cluster using one value, two value, or multiple values. So it will give, and this heat map clustering will give you an idea like which value is actually giving the right clustering or something. So for this heat map 2 function, it's in G-plots. It's older version of ggplot, and this is nothing. And you can see the plot here. So this is a heat map and the clustering. You can see those like beautiful tree clusters here, and you can see like all the variables we look into in the bottom. So from here, like you can see petal width. It gives a like a red color. So for all these 3 species, the petal width doesn't differ very much. So that's why like there's no change or very small change. Then you can see petal length, yellow, red, and mix. So maybe this one gives the most useful information about these 3 species. And then sepal width is pretty much similar to petal width, so there is no that much of difference. Sepal length, some differences happen. So you can see like, okay, maybe the petal length and the sepal length is the 2 variables that defines these clusters very well. Petal width maybe it's not useful that much. And from this bar chart here, you can see where all this error happens. Like you can see error happen here, errors happens here, some error happen here. So this is another way to do a heat mapping with the Irish data. So in the heat map, you just define like row variable is dendrogram, column variable is NA. So that's why like we make sure the column is not ordered. We define the margin, we define the color, and we define how we want to see it, density plot or some other way. And row side colors, just define the label colors of the dendrogram, and that's so far for the clustering thing here. So if you have any questions, I think ask.
So what's the difference between clustering and classification?
I think they're the same. So clustering is like a type of classification. So you can, so the difference will be like clustering or classification and regression. So regression, you are trying to find a values. So where classification or clustering, you are trying to find a, like a class or type.
Categorical variable.
Categories of variable or something like that. Okay, so if you don't have any program, so we can try some other.
In clustering, was there a way to automate it so that it would go through and try all your different distance metrics and then evaluate misclassification error rate? Is there a caret kind of thing or a mass kind of thing to compare them all?
Okay, yeah. So I just try to do different clustering. So it's average, and you can see like there's lots of error here.
Yeah.
So previously, maybe the error like distributed, so it's like particular error is happening here. So it depends on the like different type of clustering mechanism, and yeah, you can do automated things. So there is a like pretty useful clustering technique. So for this one, maybe you have to write a loop. So like define something. So define something like so you plug in Manhattan and run a loop on this thing. So it goes in each type and take the values and do the clustering here. So, Ethan, what's like? How can you plot two things on a same plot?
R,
F row,
yeah, MF row, right?
F row.
Yeah, MF row equals C 1 by 2, and you want to do par around that whole thing.
Yes.
1 by 2.
Yeah, 1 by 2 probably better.
Mhm.
So this is like two methods of clustering. One using Manhattan, then another one using Euclid. So this is just a simple loop. You can do more also. Like
Yeah.
maybe 2 by 2.
Excuse me. Is X used in the shoot you assign?
Yeah, but I don't think the method
no.
is actually working.
Yeah, method repeats. Yeah.
X of I.
X.
Or
No, X
X.
equals B.
X is taken, and I. That's your index.
Should X and 1 to 2 is what you want in the for loop.
Mhm.
Just assign that.
Oh,
Yeah.
yeah.
1
I
colon
want-
2. Yep. Okay, those are different now. I want to go back to that one. Just look at it a bit and point out the differences.
Can we make it wider, and then we'll see.
The difference is here something.
The,
Oh, yeah.
The
Yep.
magnitude's very
Mhm.
different.
Yeah. Mhm.
So yeah, you can use more maximum.
And so many times in a problem like this, if you had 10,000 values, 10,000 observations that were unsupervised, so you don't truly know the right answer. But if you could go through and manually classify the first 100 and evaluate which method is the best distance metric, and look at your classification error rate, then you'd be able to address which is the best one for what I'm doing, and then you can go use that method on all of them. So you use a small subset where you have to manually go decide. And And what's the height in the dendrogram usually? Because you can use that number.
Yeah, so
It's a measure of similarity.
it's a measure of similarity. So if you want to cut the thing, so
Yeah.
you have to define it. So generally it's 0,
Mm-hmm.
but you can define like 1, 2, 3, or -1. -1 is means same thing as 0. So like here I use hanging height is like 0.1.
Yeah.
So you can define something like that.
Because in the classification dendrograms like that, lots of times you want to use that value. It's analogous to finding the knee in the curve for how many groups you want to pay attention to. H-class.
You can see now the difference.
Oh yeah, yeah.
So now they're not hanging in the same size. You can
Mhm.
see the clustering difference between
Yeah. And these are three different
clustering methods.
clustering methods. And so since it's hard to evaluate which one you should use, if you were able to classify things manually for a small set of your data, to identify which is the best distance metric to use, and then you'll go ahead and you can apply it to all of your data. Even with numerical data, many times it can be nice to try and cluster or classify using simple 0-1 results
Yeah.
for things first, and only use regression second to try and get a more detailed understanding.
Yeah. Clustering is really useful. Like if you go look into time series data also, you can cluster. So you can see like how behavior change happens between different groups of time, and you can like classify those time and like develop different models between them, or like assign different variables, like something like that. So like we do some time series modeling of the power data, and we can define like weekday and weekend is like very much different. So you can define like some variables weekday and weekend, so it can develop different models for weekday and weekend. So this way we can use clustering.
It's actually self-similarity analysis, another name for this, is a good way of doing exploratory data analysis. Find similarities among things so you can more easily identify the differences.
This is a clustering that done by PC analysis. So like if you give some variables, so do a PC analysis, and it will give you like what are the variables you look into, and define the PC analysis, and so like what is the percentage of variable it defines, and it represents like first two PC components of this thing here. So I find this is really useful, like for my analysis.
Did you specify 3 components?
For this one,
Or,
yeah. So it does a k-means clustering here,
yeah,
and it works on the k-means clustering. So you can see k-means fit clustering.
mm-hmm. DF3. Mm-hmm. 3 right
And
there.
run like 6.
Mm-hmm. Mm-hmm.
Maybe something not useful for this case. So for 6, you can see like it defines number 1 setosa as like 4 and 5. There is nothing 4 and 5 there, so
That's a good separation.
it still does the separation for number 1 is very good. For number 2, it defines 21.
But there's a 1.
This is 1 here, but rate is small, 7, 0, that's okay. 32, 0, 0 is okay. The problem is here, number 6,
Yeah.
22, 17. You can see here, like,
Number 6 is which circle?
I think
Big
this
one right there.
This
Yeah.
one here. So it's like all over the places. So we saw like some of the sepal length is not good. So we can do only width thing. Three to 4. So if we just look into the 3 and 4. So number 3 and number 4 is the petal, and if we just go back to the heat map.
Mm-hmm.
So we can see like maybe sepal width and sepal length is the main thing. So we can do this one just based on sepal width and sepal length.
Mm-hmm.
So here we can change the clustering here. 1 to 2. So So
Yeah, that's,
that's like far
Mhm.
better.
yeah.
So still like 2 and 4 are still
Mhm.
less than.
Can't be separated. Mm-hmm.
So now we can see how the arrow changes. So this is this is so far just a basic introduction of clustering or classification. There's more, like if you need more help or anything with this script and the data, just send me an email so I can help you.
Mhm.
Thank you, everyone.
Cool. Thank you.